Hi guys, today I'll be going over a question from Energizing Physics Lesson 4.4. So this question says that a 50 kilograms physics student jumps upward. So the first part of the question asks for the student's force diagram at 0.2 seconds and 0.29 seconds. So in the picture we're given basically two different periods. One, between when the student's at rest and when they're exerting force on the ground to jump, and then the second period is after their feet leave the ground. So the first force diagram at 0.2 seconds is while the student is still exerting force on the ground to push himself off of the ground. So we can see we're given information though that at V2, which is T2, at time 0.28 seconds, which is when the student's feet leave the ground based on the diagram, and their speed at that point is 5 meters per second. So from this information we can see the acceleration, which is A equals delta V over delta T. So 5 over 0.28, and that is equal to 17.86 meters per second squared. That's the acceleration. So from the acceleration we can see the net force, because F equals ma, which is equal to 50 times this, which is equal to 893 newtons, which is the net force. So because we know the net force, we also know force of gravity, Fg equals mg, which is equal to 50 times 10, equal to 500 newtons. We have enough to draw the force diagram. So downward force, Fg, is equal to 500 newtons, and the normal force is equal to F net plus Fg, because it must overcome Fg, which is equal to 1,393 newtons. So that's at time 0.2 seconds, because he's still pushing. And this is assuming constant acceleration. So the other period to draw a force diagram for is 0.29 seconds, which is after the student's feet leave the ground. And this one's pretty simple because the only force exerted on the student is force of gravity, which is equal to 500 newtons as we calculated before, and there's no other force because the student's feet have already left the ground. So part B now asks for what time the student will reach point 3. So point 3 is when it's at max height, and V3 at point 3 is equal to 0. So we know that the the velocity when he left the ground, V2, is equal to 5 meters per second. And the only acceleration after his feet leave the ground is gravity, and gravity is 10 meters per second squared, because g is equal to acceleration. And this is negative. So all I have to do is delta V over delta T is equal to A. We know A is equal to 10, which is equal to 5 over T. T is equal to 5 over 10, which is equal to 0.5 seconds. So this is how much time it takes to slow down, but the total time is going to be the time that it started, T plus delta T, which is equal to 0.28, because that's when his feet leave the ground, plus 0.5. So the final answer is 0.78 seconds. Cool, so the last question is asking for the net force versus time graph. And we can do this pretty easily because we already looked at the two periods. In part A of the question. So in part A, we saw that during the first period when he's pressing, his net force is 1393. So we start here, 1393 newtons, and let me just focus this camera a bit. Okay. There we go. So yeah, he starts at 1393 newtons, and this continues until 0.28 seconds. And that's when he comes back down all the way to negative 500 newtons, which is where he continues until time 3. Well, actually, so time 3 is 0.78 as we calculated, so he's at negative 500 newtons, but it'll continue longer than that until his feet touch the ground again. But since the question only asks for in the diagram below, which ends at time 3, this is sufficient enough. So that's the question from lesson 4.4.